Değerli konuklarımız tekrar hoş geldiniz. Öğleden sonraki programımıza NTENT CTO'su Dr. Ricardo Baeza Yates ile devam ediyoruz. Challenges of Big, Small, Right Data and ML adlı sunumuyla Smartcon sahnesinde. The stage is yours, Ricardo.
Thank you for the invitation to be here. It's a pleasure. So normally this talk is about 1 hour, so I had to cut a lot of things, but still I couldn't cut enough, so I will go really fast. So first, I want to tell you a little bit about NTENT. I don't think you have heard about NTENT. We're not a big company, but basically we're doing semantic search and conversational search, and that's the future. So basically, instead of giving you 10 links as an answer, we give you exactly what you're looking for. So intent comes from intent, so we're predicting the intention of every query or every conversation to give you exactly what you need. So you just go to the website and you can have more information on what we do. So let's go to what I want to talk today. So today, basically, I want to talk about 5 different challenges that we have with big data, and it's about the future. And I will try to answer Ralph's question, so about predicting the future. So I'm trying to predict the future here. So one of the futures will be not big data, huge data. We will need to change the name, and I will explain why. The other one is small data, because that's another challenge. And of course, it's always about the right data. So I think we should talk about the right data, not about big data. OK, so there are many taxonomies. This is one of the most used ones of the 5 V's: volume, variety, veracity, velocity, and value. And the focus of this talk will be mainly on the red problems. This is my own taxonomy, where I divide the problems in issues with the data, in issues with computing, and issues with us, the users. And one of them is information overload, and this talk may be an example of that. Sorry, I will go really fast. So I will focus on these things: scalability, sparsity, bias, especially redundancy, privacy, ethics. So I don't think I need to explain this. Ralph and many people here, I think, although I don't understand Turkish, spoke about this. Basically, now we have more data, now we have more power. Finally, we can use neural networks, and we have improved that in something called deep learning. However, it's very important to remember that machine learning is inside artificial intelligence, and deep learning is inside machine learning. So when people say artificial intelligence and machine learning, it's like saying the egg and the yolk. So please, if you know about this, don't say and. Say particularly deep learning or whatever applies to that. And I think Ralph already talked about supervised machine learning, so I will skip that. OK, so there are some hard learning problems, and I want to give you 2 to start this. So the first one is that it's very hard to forget what you learn. A lot of things we do is not about learning, it's about forgetting what you learn. For example, what animal is this? Well, no clues? Sorry? Not so difficult. It's a cat. But the picture is taken from below a glass table. If you give this to a machine learning model, will not guess that it's a cat, because it's missing the face, it's missing the pointing ears, it's missing many other things. And then you need to basically abstract what is a cat, and for that you need to forget, you need to filter. And this is yet a problem that machine learning has not solved. And I don't have time to explain this amazing short story by Borges, but I recommend to read it. It's about a person that couldn't forget anything. So it was a pain to talk to this person because he couldn't summarize things. And the other problem we have is that we cannot learn what is not in the data. And this is one of the main problems today. If we don't have the right training data, we will not learn correctly, even if we have the best algorithm possible. It's not about the algorithm, it's about the data. And I will skip this joke. So the opportunities, I think after Ralph's talk, I don't need to talk about opportunities. Plenty of applications, like he said, to learn or explain, to predict, to prescribe. We can use machine learning for that, especially applied to personal data. For example, one of the things that knows more about ourselves is our cell phone, so a smartphone. So here we have a lot of data. But can we protect our privacy? And can we predict things here, locally, without having to go to the cloud? That's a future challenge. And very important one, machines deciding for us, what is called automatic decision making. I will go back to that. So to do this, we need to ask the right questions. I will not read all these questions, but some of them I will go deeper. But the first question is what data we need. And usually some people start with what data we have, which by Murphy's law is not what you need. So you need to do this question even though your data may be useless. The second one is about understanding the data, characterizing. That was the first step. And things like there is redundancy. I will get back to that. There are biases. This is one of the main problems today, data bias. The third is about analyzing the data, privacy issues, anonymization. I will get back to that. Scalability. That's another problem. And finally, remember, like they say in English, garbage in, garbage out. So the answer will be depending on the quality of your data. So again, right data. OK, let's go to the challenges. This will be the rest of my talk. 5 different challenges. I will not read the joke, but I do this very often because I don't want to be predicted. So if you want to be predicted, you need to do something different sometimes. You need to basically put some noise in the data. And one problem in technology is that we only know the successes. We don't know the failures. Sometimes it would be very nice to have the book of 1 million failures so you don't repeat the failure of someone else. Because at the end, failures is what teaches you. It's a learning tool to do better in the future. It's about experience. OK, so the first challenge. Let's take the long data for people. So this is the long tail applied to people. So you have here all the people. Let's say you have 4 billion people connected today. And this is the most crazy YouTuber. He's producing 10 megabits per second because he's taking video all the time. So there are some people like this. Not too many people. It's a good thing. So this is big data, but not too many people generate big data. And most of the people generate little data. This is called activity bias. This is the fifth law. It's a very old law. So some people do a lot, most people do very little. And this is good for the web. This is good for all our activities, because imagine if all the people were doing as much video as you can. Because remember, the best you can do when you double the data is to double the time. So we don't have infinite time. So what happened with the Internet of Things? So let's put the Internet of Things in context. So here, I have the same graph as before, which is reduced because a sensor can do like 30 megabytes per second. And there are some predictions that next year, we will have 10 billion sensors, much more than 4 billion people. So basically, I put the old graph here. And what is the problem with sensors? Well, sensors don't have activity bias. They are not like people. They work all the time. So we don't have a power law. We have a box. So this is the amount of data that will come from sensors in the future. It's much, much larger than the amount of data coming from people. So this is about 300 petabytes per second. This is 1 billion times bigger. And this is where we need to change the name. It's not about big data. It's about huge data, fast data. I don't know. We'll have a new name. And this is coming in like 2 or 3 years. And the main problem is the bandwidth bottleneck. If you need to handle 300 petabytes online, this is too much. For example, 1,000 sensors will be 2 gigabytes per second. That means if you use 5G, which is one of the near futures, that is 1 gigabyte per second. So this is not even enough. If you use fiber optic, it's 120 gigabytes per second. And one solution is to use a plane to transfer data. So if you take the biggest commercial plane full of Blu-rays, you get about 38 terabytes. Someone in 2010 computed this. Airplanes are not bigger, Blu-ray is still the same. But we are there, like 50, 100 terabytes. This is our limit. It's not petabytes. Of course, recently they did this. If you remember the black hole image, they had to carry 700 terabytes of data, and the easiest way was to take a plane. So the planes took 14 hours from Hawaii to Boston, and they reached 14 gigabytes per second. This is a very high bandwidth. OK, what is the solution? Hierarchical edge computing. This is one of the solutions of the future. This is one of my predictions. OK, second challenge, sparsity. The same problem, the long tail of data, but now for companies. Now this is data for a company, and these are all the companies in the world. Well, there are few that have big data, only the big companies. Most of the companies in the world have small data. The bakery in the corner will never have big data. Most stores will never have big data. So why we're so obsessed with big data? Why we're not working on machine learning techniques that work well with 1 gigabyte, or at least to answer the simple question, I would ever be able to use machine learning with my data? Very simple question. I think this is the next problem that scientists will need to solve, and there are many reasons. Here I will put some of them. I will not read all of them. It's in a blog posting in KDD Nuggets. You can read it. It was October last year. So this is plenty of reasons, and even there's a book about small data, very interesting, that says that innovation comes from small data. Because we cannot handle big data. We need to understand data, look at the outliers, look at special cases, and then we come up with idea. We don't need big data to come up with idea. We need unique data, right data. OK, third challenge, redundancy and bias. So redundancy is the problem that if, for example, with sensors, you may have a lot of repeated information. Like if we take all the cell phones here, they're all taking the temperature, but do we need 100 cell phones to tell us the temperature? We just need one. If we take too many, we may get some mistake. We may think that something else is happening. Biases. Well, there are many. Gender, race, and so on. I will go back to activity. Activity bias, very important. Biases that are put by the algorithm, not by the data. So when I say algorithmic bias, I mean not data bias, I mean bias that was put there by the algorithm. And let me give you some examples. So this is data from the UK. It's justice data. So here you see the population in the UK in 2014, arrests, prosecutions, convictions, go to prison. Well, if you're a black person, the probability increases by 4 to go to prison. So any machine learning algorithm will learn this, even if they don't have the demographic data, because it's encoded in the data. So there are many examples of how algorithms learn to be racist. And even that they're racist, they can be better than people. The main reason is because they always do the same. So at least they are fair in that sense. Gender bias. And usually I give this example, and no one speaks Turkish, so here is different. So I write, he's a babysitter, she's a doctor. I translate it to Turkish. I cut and paste this here because I don't have any idea of Turkish. And then I get the opposite. She's a babysitter, he's a doctor. A few months ago, Google fixed this for one sentence, but it still has the same problem with 2 sentences. What's the problem? Well, you know very well. In Turkish, genders don't have pronouns. And then here, Google is using the most common thing in the text that is used for training. And the most common thing is that she's the babysitter and he's a doctor. And there are plenty of papers about this. And the problem is that most text in the world has gender bias. So be careful when you use word embeddings because they're biased there. Let me give you another example of gender bias, more subtle. This comes from one of my PhD students. And these are biographies of women in Wikipedia, sorted by year. I'm not a historian, but I think the French Revolution changed things. So, equality. So you see that this has been improving. Now we are at 24%, but still not 50%. So you can say, well, there's nothing wrong here. It's systemic bias. But no. The real bias here is that most editors in Wikipedia are men. For example, for biographies, only 11% are women. And this is also biased because many women prefer not to say their gender because of saying that. And maybe the real number is 15%. But still, there's a lot of bias there, much more than 50%. So many times there are hidden biases that we don't notice. Let's go back to activity bias. How many people do things? So this is the work of another of my PhD students that now works on the Wikimedia Foundation, so he works on Wikipedia. So if you take active users, and nobody exactly knows active users because you don't see them, you don't see the passive users, so only every platform knows about this. But these are less than 10%. So we are taking the less than 10% of the people. And we took 4 different data sets, one from Facebook, small, Amazon, large, Twitter, very large, Wikipedia, old Wikipedia. And we asked the following question. How many users produce half of the content? So the democracy of content. For example, in Facebook, we found that 7% of the people produce half of the post. That's why it's this here. So 7% produce half, and the other half, 93%. Amazon, 4% of the people produce half of the reviews. Well, when I said this, there must be something wrong. People cannot be writing reviews. Check it. We check it, and 1 month after we published, Amazon started to prosecute false reviewers. I don't know if they read my paper, but it was exactly 1 month later. So this continued in 2016 and continues today. If you see very few reviews and all positive, most probably they're all fake. What about Twitter? Even worse, 2% of the tweets, 50% of the tweets were done by 2% of the people. Not surprising, there's some people that cannot be without tweeting. It's called ego, so easy to explain. And then only 2,000 people did half of the English Wikipedia, and they were paid. I guess that's why we have Wikipedia today, because we started with something that was not half empty, and now it's half full. Also, there's a long tail of attention. With Diego also, we look, another problem I was interested. How much content in the web is at the end of the attention? Nobody sees that content. And we found that the Wikipedia, for example, 31% of the content, new content, was no one will look at that for a month. Even worse, we found that in Twitter, more than 1% of the tweets are done by people that don't have any followers. I hope you understand how Twitter works, but if you don't have followers, it's like going to the Sahara Desert and screaming. Nobody's listening to you. Algorithmic bias. I think I will skip this example because I don't have enough time to finish. But basically, sometimes you don't need to help people because the only way to improve algorithms is data coming from people. And if you help people too much, people will give less data. And this is the idea of this example. But let me give you the worst part of algorithmic bias. It's on the interaction. So the first one is called presentation or exposure bias. Everything in this page may have a click. For sure, everything that is not in this page will never have a click. So millions of things will not have a click because the system decided to put only these ones in the screen. The second important one, ranking bias. People believe in computers, believe in algorithms. So people click more on the first position only because it's in the first position. This is ranking bias. Now, search engines noticed this a long time ago and are biasing this. They are fixing this. Otherwise, you will believe you are great because you get more clicks on the first, second position, but it's not true. It's the ranking bias. Social bias. You think that something is bad, but you don't put 1 star because most people have 5 stars. So you decide to put 2 stars. That's social bias. Your opinion was changed by the rest of the people. And finally, there are many other interaction biases, like, for example, a scrolling bias. Some people don't scroll, and they don't see what is below, and so on. Also, we have second-order bias. This is the most subtle bias I will show here. And this happens in personalization, too. Let's say you are writing a blog posting, your new blog entry, and you do a search in your favorite search engine. This will be your new page, and you click on the top results because you have ranking bias. So you take these 3 pieces of text, you put it in your new blog entry, you feel some shame because nothing's yours, so you put something coherent that makes things. Of course, I'm not doing plagiarism, so I will put quotes, a link back to the source, and the author here. I'm doing proper research. And then I put my name, because it's my entry. This is the ego part. And then I publish that back into the web. What's the problem? The problem is not that this had also ranking bias. This is biased to what this search engine thinks is good. So it's biased not to the position, it's biased to the ranking function of that search engine. So basically, what is good depends on what the search engine thinks is good. So next time you write something, please write it from scratch. Don't use other content. Otherwise, you are just replicating a ranking function. We show in this paper, another PhD student 10 years ago, that the semantic redundancy is over 30% on the web because of this process. OK. Next problem, the filter bubble. How many people have read this book? Basically, I only met Toygun yesterday, but imagine I know him from when he was a kid. I can use his data and predict exactly what he wants. However, I will never be able to tell him something new, because it's not in the data, that he may like it if he knew it. Maybe you know this movie, and then that's more clear. So this person was very happy until knew that he was living in a bubble, and then you want to get out of the bubble. Search engines and recommender systems are fighting this with diversity, novelty, serendipity, but I would like to see something else. I call it the opposite side. I want to know how far away is the other people different from me. I want to know the whole size of the universe. And that may be scary, but I think will help us to understand our own biases too. OK. So if you want to read more about this, I wrote all this in an article called Bias on the Web last year. And it's basically about the vicious cycle of all these biases on the web. Now, one question is, what about the software? What about the code? Do women write code different than men? There's no experiment yet, but I think the answer is yes. Let me give you some similar experiment data science that the Center of Open Science did 2 years ago. And it was very simple. 29 teams got all the data of the Champions League, and they asked the following question. Do black players receive more red cards than white players? Yes or no? So there is race bias or not? Well, 20 teams said yes, 9 teams say no. This is a bit surprising, but for me it's not surprising. What is really amazing is that if you know a little bit of the statistics, no team did the same. And this is our professional biases at work. These are the 29 teams. This is the equally likely hypothesis. And you see some teams didn't know what was a confidence interval. Some teams got a huge confidence interval. No people used the data in the same way. No people did the same as statistics and so on. So we do things differently, and that also affects the result. The before last challenge, privacy. And now we have a challenge of GDPR that you have to comply with it, even that for a small company doesn't make sense. So it's not good for everyone. So privacy is a problem. And many people thought that was not really a problem until 2006, when using a query log, 2 journalists of the New York Times were able to identify one person in a query log. This person was nice, didn't sue the company, but showed us that it was much easier to guess a person from data than we thought. There was a case A few years later, for the Netflix contents, using IMDb data, and that did go to court, and that was much more complicated. So, the last one, ethical issues. Problems with accountability, problems with moral dilemmas. Can we have ethical algorithms? Maybe. So 2 years ago, ACM policy team said these are the 7 properties that an algorithm should fulfill. I will not read the properties. Well, the problem is that today no algorithms fulfill these properties. And this could be very dangerous if some other group takes over how we fulfill these properties. Now, algorithms don't have to be perfect. Just they need to be better than humans. Like, for example, a self-driving car may kill someone, yes, but I'm sure they will kill less people than, say, drunk drivers, because drunk drivers will not be able to drive. OK, that means we need explainable AI, and that would be a completely different talk. But basically, we need to do contestability. Basically, remember, all these are predictions. Predictions might be wrong, and people have the right to complain. So we need a channel to do explanation and contestability. And this is one challenge in the future. OK, some recommendations. I will not go read all these. So these are some. I will publish the slides later. But this could be the future. And these are my 2 last slides. See, this is really my worry. It's not about artificial intelligence. It's about us. Every election, I see this. Right? The last one was Brazil. OK? And if you have read last Harari's book, it's a very pessimistic future. And then this may happen. Prove that you're not a human. There are no more humans. Correct. Ha ha ha. And this is not because the robots kill the humans. It's because the humans kill themselves. So to the end, and Ralph said this, can we predict the future? No, but we can invent it. The first person that said this was Dennis Gabor. In this book, it's called Inventing the Future. Alan Kay's citation is more known. And why we don't change this one by this one? That we invented the future in some smart con in the future. Thank you.